Exponent laws are the set of rules that apply to mathematical operations that you do on powers. A power is an expression that has a base, that's this number down here, or variable, and an exponent, that's the number that is written to the top right of the base. It shows how many times that thing is multiplied by itself. X to the power 5 means x times x times x 5 times. And x to the power 6 means x times x times x 6 times. So when I do something like this, when I have x to the power 5 times x to the power 6, really this means x times x times x times x 5 times x times x times x times x times 6 times. I'm multiplying together 5 x's and I'm multiplying that times 6 x's. What ends up happening is that I'm multiplying x times itself 11 times, those 5 and those 6. That's what I end up with, that single base and that exponent. And that is one of the exponent laws. That's one of the power rules. So I'll show you what those are, broken down one by one. The first one is the zero exponent rule. The rule is that any base to the exponent 0 is equal to 1, the whole thing. That's true except 0. So technically, if you had, whether it's a number, positive or negative, and if it's negative, we put it in brackets like this. The reason is because of the order of operations. Exponents come before additions or subtractions. I would have done, without the brackets, 2 to the power 0 first, and then applied the negative sign. But if the whole thing is in brackets, it means that I'm applying negative 2 to the power 0, whether it's positive or negative, anything to the power 0 is 1 except 0. So technically, in a case like this, I would have to specify that x is not equal to 0. That one is a bit of a different rule. Anything to the exponent 1 is equal to itself. Any base to the exponent 1 is equal to the base itself. And that's true if it's a number, positive or negative, or if it's a variable. So mathematically, if you have something to the exponent 1, we don't write the 1. It's implied. Multiplying powers means that when you multiply two powers that have the same base, the product is the same base to the power, to the exponent, the sum of the two individual exponents. You add the exponents. So the base stays the same, 5 to the power 1 times 5 to the power 6, and this 1 wouldn't have to be written there. I would add those exponents and the base stays the same. It doesn't become 25, it stays 5, and the exponents add, and that's true whether you're adding positive numbers or negative, whatever. The opposite of that rule, dividing powers, I would have, when my base is the same, my quotient will be the same base, and my exponent will be the difference, subtracting the two individual exponents. So again, that's true whether I have a numerical or a variable base. So here I didn't divide the 5s, 5 to the power 10 divided by 5 to the power 6. Those aren't coefficients, they're bases, and this is how I deal with those. If I have a power raised to a power, the way I deal with that is that I multiply exponents. So here, y to the power negative 3 all to the power negative 4. I multiply the two exponents. That's my new exponent on the result. And if ever I have a negative exponent, I have to write it as its reciprocal. That means it's flipped. Something on the top of a fraction moves to the bottom. Something on the bottom of a fraction moves to the top. So x to the power negative 2 really means 1 over x to the power 2. 1 over y to the power negative 3 means that this y to the power negative 3, the y moves back up and becomes positive. My final answer should only have positive exponents, so I need to move things around accordingly. And in a case like this, where I have a coefficient and a power with a negative exponent, the 2 doesn't have an exponent at all, which means that really it's 1, which is positive 1. It doesn't move. The 2, which was in the numerator, because this whole thing is over 1, that 2 stays in the numerator. It's just my n to the power negative 4, just the n that moves to the denominator. So the problems that you will be dealing with have sometimes more than one of these rules put together. Like in this case, I have this multiplying powers rule, but I also have a regular multiplication, like 2 times 5. That's just a regular multiplication. 2 times 5 is 10. And then for the x's, those two multiplied together, only things with the same base follow these rules. And this wouldn't have had to have been there at all, but I would add 0 and 6. And here I would add the exponents 3 and 4. In this case, I divide my coefficients, 20 divided by 5. I subtract -2 minus -5, -2 plus 5, and 7 minus 6. That's how I end up with this. And in this case, if I end up with 3 times 3 is 9, the x's, when I add -4 plus 4, those cancel out. And y, 3 minus 5 becomes -2. So there are two rules that I'm following here. A zero exponent I don't write. It's just equal to 1. 9 times 1 is 9. And y to the -2, because it's a negative, moves to the bottom, and I rewrite it as a positive. When you are dealing with very complex problems that have a whole bunch of steps, this is an example of steps to follow. You don't have to follow them exactly like this, and I'll explain how. So one thing that I will do typically first is if ever I have any zero exponents, I'll just get rid of them. It makes the problem a little bit simpler. If there's a zero exponent, it doesn't really change anything anyways. Next, if I have something in brackets to an exponent, I'll get rid of that first. I will often apply that. But you might want to simplify things inside the bracket first. Maybe it's easier if you simplify it a little bit, then you don't have to apply exponents to such big numbers, and you can absolutely do that first. So you don't have to necessarily follow these in order. To move all the negatives, so anywhere there's a negative, I move it up to the top in this case, or this one I move down to the bottom, they become positive, just so that you're not dealing with negatives. And then once I've gotten rid of the negatives, I can group things together, the product rule. So up on the same line, where I have x's together, I can add their exponents. Where I have y's together, I can add their exponents. And then my quotient rule, here I have y's and y's, I can divide. And 10 minus 14 is -4, so I would leave that at the bottom, or move it back to the bottom. And finally, I would simplify these numerical coefficients. 2 to the power 2 is 4, 4 squared is 16, 20 squared is 400, and simplify, and that's what I end up with.